Welcome back to another Lapis Guides Introduction to QGIS tutorial. Today we're going to be working with digital elevation models. So basically these are special rasters that are created from satellites that are producing a grayscale raster where different colors along the grayscale spectrum mean different elevations. Right? And we can take these digital elevation models and we can create aspect models or slope models or a variety of other things, and you can use them for a lot of different environmental work. Today we're going to look specifically at taking a digital elevation model from near the city of Balakchi in Kyrgyzstan and doing a fictional project where we are trying to reforest some south-facing land within a specific slope degree. So that way we're not working on arable land for farming, but we're also not trying to reforest spots that are too steep. And how can we use QGIS and a digital elevation model to figure out exactly where the best places are for doing the planting? Right, so the first thing that we need is we're going to need our digital elevation model. So I'm just going to quickly find the two files that we're going to use. These are available for you as well in a link. All right, so we've got two files here. The specific location that we want to work with is right on the border here, and so that's why we need both of them. So that we only need to work with one main file, let's turn this into a virtual raster. All right, so we'll go to raster, miscellaneous, build virtual raster. Our input layers, we're going to select both of them, right? High resolution, but we are going to uncheck this box. Before, when we've used a virtual raster, we've been doing that with Sentinel imagery with bands 2, 3, and 4 in order to create a color raster. So we needed to have them in separate bands. In this one, we don't need separate bands. We're actually just putting this, basically just stitching it together, right? So we don't need these separate files because they're not overlapping, they're side by side. Okay, so we don't need different bands. And let's save this to a file. And we can remove these now. Great, so here we go. Here's our virtual raster. Okay. The next thing that we need to do is we actually just need to clip out the section that we need. All right. So we're going to clip by extent. We're going to go in and we're going to select extent on the canvas. Okay. And somewhere in this general area. That's about all we want. And we'll save this as Balakchi area clipped DEM. Great. This will make processing times later on a whole lot faster because sometimes this takes a lot of processing power to do some of the work. Okay, so the first thing that we want to do is we want to create an aspect map. Basically, all that means is you've got a compass with 360 degrees, 0 degrees is north, 90 degrees is east, 180 degrees is south, and 270 degrees is west. Right? And we're going to create a map where each degree is shown based on the direction that that piece of land is facing. All right, so it's really easy. We'll just go up to raster, go to analysis and aspect. Okay, got the right raster on there. And we can just keep it as a temporary file for now because we're not going to end up using it in the end. All right, so we'll click run. And great. So basically, I'm going to get my identifier out. And I can click anywhere and it will tell me the degree that that piece of land is facing. All right, so anywhere I click, it will show me a number. All right, and depending on that degree, we know which direction on a map that piece of land is facing. Great. So the next thing we want is we want to create a slope map, right? And this is kind of the same idea, except instead of the degree that it's facing, we're going to say the degree that the angle of the land is in relationship to just flat, okay? So to do that, the tool that I use, I go to my processing toolbox, and I go to slope, and I use the grass plugin, R slope aspect. And since we already have aspect, we don't actually need to have this one in there. So we can come in and we can uncheck all these extra boxes. Okay. I want to make sure that my raster is correct. I have it in degrees, all right, and everything looks good. So we'll just run that. Might take a little bit. All right, great. And there's our final result. We can zoom in and make sure that this is selected. We got our identifier tool, and we can click anywhere here, and we can see that the slope is 4 degrees. We can see the slope here is 34 degrees. Okay, the slope here is 56 degrees, right? So when we're looking at where are good places to plant trees, right, we want to make sure that we have them facing the right direction, all right? And in the northern hemisphere, south facing is going to be better because it allows us to have more sunlight for the plants to grow. So because we want things that are south facing, we need to take this aspect map and we need to filter out everything that is not south facing. If we look at places like this, right, this is 26 degrees, almost 27 degrees. This is very close to 0, and so we know that it's facing north. But when we look at places over here, 161.5 degrees, that's definitely going to be facing more southwards, right? So southwards facing will be better for planting trees than north facing. Now there's a way that we can take this aspect map and we can filter out everything that is not south facing. Okay, it's really easy. We just go to our raster calculator. Okay, we're going to say aspect is greater than or equal to 90 and our aspect less than or equal to 270. So basically what that does is it tells us that everything that is between 90 degrees and 270 degrees, or everything that's facing south then, that will be given a value of 1. Everything that doesn't have that will be given a value of 0, right? Make sure that we save that. Aspect south. Okay, and we'll run that. And that gives us this map. And so everything that's black, that is facing north. Everything that's white, that is facing south. Now, yes, obviously we've got a lot of little tiny bits and pieces in here, but that's okay for now. We'll clean that up later. Okay. So the next thing that we want to do, we now know where we can plant our trees based on the direction that the land is facing. The next thing that we want to know is the slope, because we don't want to plant anything on slopes that are useful for farmland, right? But we also don't want to plant anything on slopes that are too steep where it's fairly inaccessible and likely not to have a lot of organic matter and dirt anyways, right? So we're going to do the same kind of thing with our slope map. Right, let me hide these. So here's our slope map again. We're going to do the same kind of thing with our raster calculator. We're going to come in and we're going to say our slope is greater than or equal to, let's give a value of 8, and our slope is less than or equal to, let's say 30. It's a little bit steep, it's getting on the edge, but we'll keep it all the way up there just in case. Okay, and let's make a new file for that. That's slope 8 to 30. We'll save it and we'll run that. Okay, and there's our new slope map. Okay, so again, everything that is black does not meet our criteria. Everything that is white does meet our criteria. And now obviously, if we just look at our aspect south map, this does not take into account any of the slope. And if we just look at our slope map, this does not take into account any of the aspect. So what we need to do is we need to combine these somehow so that we can find each pixel that meets both of our criteria, south facing and within the correct slope range. And again, it's really easy to do that. Since we know that the white values have a value of 1 in both of these maps, right? And we want values of 1, we can do a simple multiplication in our raster calculator. Okay, so we'll do a bracket. We'll say aspect south times slope 8 and 30 equals 1. Because anything else is going to equal 0. If we have the wrong aspect but the right slope, that's a 0 from the aspect and a 1 from the slope. 0 times 1, 0 times 1 in here will always equal 0, and so it will not equal 1. Okay. Likewise, when both locations are incorrect, 0 times 0 will be 0. So we will only end up with white values, right, 1s in our following map when we have the correct values. Okay, so here we go. We'll save this as planting regions. We'll run that. Okay, so now everywhere that's white, these are places that meet our conditions. Okay. All right, so like I mentioned earlier, there are a bunch of spots in here that just tiny little bits and pieces that we're not going to come in and we're not going to plant a tree on something that's 1 square meter, right? It just doesn't really make sense. So we need to do a little bit of sieving to clean this up. All right, so go to raster, go to analysis, sieve. We'll make sure we have the right raster. Put this at 8, so you use 8 connectedness. All right, and let's just run that. Cool. But as you can see, this doesn't really look like what we were wanting it to look like. And that's because we have values of 1 and then all the way down to less than 0. Right? And all we want is a raster with values of 1 and 0. So what we're going to do is we're going to go back up to our raster calculator. We're going to create a new raster based on our sieved. If the sieved is less than or equal to 0, and we got to put some brackets in here, then we'll say that it is equal to 0. So anything less than 0, we're just going to make that value 0. Okay, we'll save that. Great, and that looks a whole lot better. All right. Okay, so the next thing that we're going to want to be able to go and do is we're going to vectorize this raster so that we can start looking at the areas, so that we can take out the ones, the spots that have an area that's too small for us to worry about. Again, we're not going to run around and plant trees on every 5 square meters. We want to focus on the large areas where we can do proper reforestation projects. Okay, so the next thing, we're going to go up to raster, conversion, and we're going to turn this into a vector and make sure that we have the right one here. Okay. And let's run that. This might take a while depending on the processing power of your computer, because it's going to be creating a lot of little tiny polygons for all of these little spaces. So be patient. Right, and once you've got your vector, then we can move on to the next part. We only want things with a value of 1, right? That's where we know that both of our slope and our aspect matched up the way that we wanted. Right, so what we can do is we can come in to our to our attribute table. We can come into our attribute table. We can turn editing on. we're going to select features using an equation. Fields and value d of n, if it's equal to 0, then we will select it. Okay. And we can just right away, we can delete anything that is a 0. Let's turn editing off. Let's have a look at what we've got left. Let's hide everything underneath. That way all we see is the things that we're working with. And you'll also notice when we zoom in on things, we've got a lot of little holes. Okay. Before we can deal with this though, we need to reproject. Okay. So let's reproject this into our UTM zone 43 north. Okay, we know that that's one that works really well in Kyrgyzstan. Right? And that way we can do some work with actual area. And I'm not so worried that right now that I'm working in a different spot or whatever than the things underneath, right? Because if I turn this on, it's not going to show up underneath. I'm not so worried about that anymore because what I'm doing with this is just working directly with the file. Okay, so what I want to do now, I want to come into my attribute table, all right, turn editing back on, and I'm going to use my field calculator. I'm going to create a new field. It's going to be called area. Again, this is a decimal number. Let's give it some good precision and write our equation area times 1 million. That way we've got it in square meters. Okay, great. Now, you can see we've got some places that are really large and some that are very, very tiny. All right, so let's toggle that off, save it. Great. And like I said, we've got a bunch of little holes. And what we're going to do is we're going to come in and we're going to fill up these holes. Okay, so go to our processing toolbox. We're going to delete holes. So just search for hole. You'll delete the holes. Remove holes with an area less than, let's say less than 20 square meters. Okay. So we'll run that. Closed. Great. And that's cleaned that up really, really well. Right? If we compare these two, right? We've cleaned that up really well. Okay. The next thing that I want to do, I want to take away all these little bits. Okay. These aren't really very important. And again, it's really easy to do that with my attribute table. I can come into my attribute table, toggle edit mode, okay, and I'm going to select using a feature, select using an expression. I'm going to say area is less than, and let's say less than 20 meters, 20 square meters. We're going to select those features. Okay, and I don't need them. Yeah, let's save that. Let's take away the one underneath. Okay, and we can start to see that the region that we're working with is a lot cleaner than what we had at first, right? Okay, these are a lot cleaner. Let's just have a look and see what the size is of some of these smaller pieces here. Look at like this one here. Okay, so this is 21, almost 22. Okay, this one's almost 40. It's almost 122, 90. All right, so basically we've gotten rid of a lot of the small pieces, and we got larger ones that are quite a lot larger. So we know that these are areas that we would be interested in looking at for reforestation because they meet our criteria of being south-facing. They meet our criteria of having the right slope, and they meet our criteria in terms of being large enough to actually work with. Okay. Also make sure, because right now you've just got a temporary file for this file, you should probably also export it as a shapefile. Make sure your projection is correct. All right. Now, it did take quite a lot of effort in order to get to this point. All right. And one last thing we can do just to check it with like a regular Bing map. Okay, we can let's duplicate this layer. All right, and let's set our layer projection at just the normal 4326. Okay, we'll zoom to that, and then we can pop on like a Bing map underneath. Right, and we can see on the map locations that might be suitable for planting trees. Let's change our style really quickly. So if we start zooming in, we're going to notice that by and large, we have avoided agricultural zones, right? We've avoided places where there are people living, but we have found locations that are appropriate for planting. It's really interesting how people really try to avoid building on slopes that are more than 8 degrees. So yeah, once you have this final map, just spend a little bit of time zooming in and out, looking at the places that look like they could be forested through this project, and see if it matches up with what we see on the map, if our model matches up with that. And so far, I think I'm pretty happy with what I'm seeing. There might be a few spots that maybe we could have done, instead of 90 to 270, maybe we could have done something a little bit more like 75 to 295, right? Adding a little bit extra, because during the summer, because of our latitude, during the summer, the sun actually rises and sets at a different degree than just 90 and 270. That would be more appropriate at different latitudes, but because of where we are during the summer, the trees would get enough sun at different aspects that it might be worth going back and fixing our aspect map a little bit and going back through the process to refine this model a little bit. That's why we do this. That's why we come and we look and we see if the things that our model shows us are accurate. We can do that with the computer first, and then we can also go outside and we can spend time outdoors looking and checking. Obviously, soil type will be something that we need to take into consideration later, or moisture amount, right? Different things like that. Those are going to be different things to take into account as well to know if these are going to be appropriate places. And so when we did our calculation to create our planting area, based on slope and aspect, we could also create other rasters first for soil moisture or soil type, and basically create a larger equation where aspect times slope times soil type times water moisture. If all of those line up to give us the right variable, then we would know that that's a location that would be good for planting. Right? We may have some issues where now we need to overlay a vector map of where people are using pasture land so that we're not planting trees right where people are taking their sheep. But this is a great starting point, at least. So this is how we can use the digital elevation model to create further models for maybe that's reforestation. Maybe that's where you might want to grow a vineyard, or maybe that is actually finding a suitable location for building or for agriculture or different things like that, right? We can use a digital elevation model to show us all of these different things so that we can make correct decisions on the problems that we're working with. So hopefully this tutorial was useful for you. Hopefully you learned something from it. Let me know if you have any questions in the comments. And yeah, see you for module number 9.